we're still on problem number 5. We're on B now. And they said let Bn be the approximation to area under the curve. Y equals sine x from x equals 0 to x equals pi. Well, we just did that for A, but for the midpoint rule, now they want to use this trapezium. So really a trapezoid, all right, with n strips. Each is going to be pi over n. Show that Bn times the sine of pi over 2n is equal to pi over n. Oh, wow, looks pretty complicated. I'm hoping it's really the same story, though. Let me go to B. And this is, again, 5B. We just did A. I'm going to write down Bn. It's the trapezoid rule. And I'm going to kind of try to write that down. I want to remind you what we're doing. We're doing an area, 0 to pi. And we're using a trapezoid rule. And this is a sine function, by the way. Let's put it down. Pi, I'm using the trapezoid rule now, over 2n. Got a nice pattern to it, though. It's going to be sine of 0. That's where we started. Let's see, plus, it's going to be a bunch of 2's now. So sine, I just move over 1, so pi over n. That's what the partition size is. And it's going to be a bunch of 2's. All right, so next one's going to be, 2 sine 2 pi over n. And next one will be 2 times something. And eventually, it stops doing the 2 at some point, and that's going to be sine. It's going to be n minus 1 pi over n. This is 1 before the end of it, by the way. And then there's going to be this n value, which is sine of pi. All right? Okay. I'm going to keep writing this thing down because I realize that right now it really doesn't look like what I want it to look like, but it's sort of getting somewhat close to it. All right? I'm not saying it's there yet. So I'm going to say Bn is still pi over 2n times, well, the sine of 0 is just 0, and the sine of pi is just 0 as well. So I think what I can do is just write it down now with just those middle terms. They got 2 in it. So it's 2 sine pi over n plus 2 sine 2 pi over n plus, there's a bunch of 2's, by the way. Last term plus 2 times sine. That's going to be n minus 1 times pi over n. All right? So, again, I'm looking at it. I wonder how it relates back to the other one. Let me think about this. I'm going to try something maybe a little bit tricky. And the one thing I'm going to do is just multiply both sides by sine of pi over 2n. Let me do that now. So Bn times sine. Now you may wonder why I'm doing this because I'm seeing this in what they want me to show, but I don't see what they want me to, how this works out. But I do know they want me to do this. So I'll put this pi over 2n times, and I got to write this down. It's kind of complicated to write down, isn't it? It's 2 sine pi over n, that's that term there, times sine pi over 2n. And not that I can write that every one down, but I can write the next one down certainly. It's going to be 2 sine 2 pi over n times sine of pi over 2n. I'm going to keep looking at this, right? Plus dot 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 plus 2 sine n minus 1 pi over n times sine pi over 2n. All right. Boy, this really does remind me of the beginning of the other problems, doesn't it? And I want to go back and look at that. And I sort of remember doing that, right? We have 2 sine theta. All right, I get troubles over here. I'll tell you what the troubles are. I'm not really seeing exactly what I want to say. I get pi over n. We're a little differently. Let's do that. So pi over 2n, 2 sine, I'm going to write it as 2 pi over 2n times sine of pi over 2n. Let's go to the next term. Again, I'm trying to get some understanding that this looks like the original thing that we just did. So that's going to be sine 4 pi over 2n times the sine of pi over 2n. All right, let's keep going. Plus yada, 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 plus 2 sine 2 n minus 1 pi over 2n times the sine of pi over 2n. All right, I gotta start thinking now. And this really does go back to the original problem, by the way. And we just did that. I just really have to go back and look and make sure I just did do that to derive that formula. And look back over the notes that we just did. And again, I hope you have a copy of what we just did on the board, by the way. I'm not going to scroll back. I probably erased it anyway, but I do have it written down in paper. Yeah, I think I did that. And we get that telescoping series again, all right? And let's write that down. It's telescoping, all right? And what happens? Things just disappear. Let's write this over here. It's going to be pi over 2n cosine pi over 2n. Remember when we spread these things out before using that formula that we were given, that things did cancel off telescoping. And we had this beginning, and then we had this end part, minus cosine of 2n minus 1 over 2n times pi. You know, I'm going to write that a little differently. And let me just get my eraser out. And just write that down a little differently. So I'm going to write it as 2n minus 1 times pi over 2n. All right. I'm still looking at this and wondering what to do at this point. I got the pi over 2n, and I'm looking at this difference. I'm going to rewrite it as a product. And that's going to be 2 sine, let's see. I've got to think now. All right, so let me put this down. N minus 1 pi over 2n times sine of pi over 2. Let me just go back and make sure that we did do something like that before, so I'm not making that stuff up. Yeah, we did that before. All right, so let me look at what I can do with that. Let's take a look. So I guess what I could do now is pi over 2n, and write that as 2 sine n minus 1 pi over 2n. Oh no, I just did that. I'm going to do that again. Pi over n. This 2's cancel off, by the way. I'm seeing this over here, and I'll write this as sine pi over 2 minus pi over 2n. Wow, will this ever end? Well, I can do a cofunction identity now, can't I? So pi over n times the cosine, and that's going to be what? Cofunction identity over here. Is that going to be minus pi over, no, pi over 2n. All right, I gotta go back and see if that's what I was supposed to do, by the way. And I think that's exactly what I was supposed to do. Let me just go back over and look at that. And they were asking me to show that this here, let me look back at the notes, that bn times sine of pi over 2n was the same thing as this thing over here. And I think we just accomplished that. Yeah, we did. We're done. QED. Thank you.